Hi there. You'll be able to find all the lectures and the worksheets that go along with the lectures if you're going to be doing them in paper form, or if you know somebody who doesn't have access to the internet and they need paper forms, tell them they can go to the high school office, and everything that I'm doing online is available in paper form at the office. So there'll be lectures and worksheets. Hopefully they'll be able to get online to see the lectures. They're on YouTube. All right, this is ellipses. We're going to graph ellipses. It says and find their foci, but we're going to ignore the foci today because due to the limited time we have, because of the COVID-19 shutting down the schools statewide and whatnot, we don't have as much time as we would like to have to spend on all this stuff. So what I'm going to try to do is just teach you how to graph an ellipse and find the vertex and the covertex, the vertices and the covertices, and graph them. And on your worksheet, it'll just be multiple choice. It'll give you the equation of an ellipse, and it'll give you 4 graphs of an ellipse, and you just got to pick out the right ellipse, A, B, C, or D. So here we go. Hopefully this will give us enough of an idea of how to do that. Student will graph ellipses. We're going to ignore the foci for now. You'll hear that called foci when you go to college. Here we go. Ellipses look kind of like eggs. They may be laying down on their sides, or they may be standing up on edge. You think of them as ovals. We've named parts of these. The parts that are furthest away, if you were to cut this thing in half, the oval, the ellipse, cut it in half the long way, each end point of the line segment cutting them in half is called a vertex. That's a vertex. That's a vertex. The plural of the word vertex is vertices, so these are the vertices. If we were to cut it in half the short way, each one of these points at the end of the line cutting it in half the short way are called covertices. That's a covertex, and that's a covertex. The distance from the center of the ellipse to the vertexes, we're going to call that A. We'll call the distance from the center to a covertex B, and from the center to what we call the foci, for a focus, for instance, we'll call that C. They're related to each other mathematically. That's all I'm going to say about the focus, and I'm going to continue onward through the fog. This is the major axis. This is the minor axis. The covertices are on each end of the minor axis. The vertices are on each end of the major axis. The major axis cuts it in half the long way. The minor axis cuts it in half the short way. Vertex, vertex, covertex, covertex. If it's standing up, the major axis is vertical. So the vertex is at the top and bottom instead of left and right. The vertex is at the end of the long line segment that cuts it in half. If you cut it in half the short way, each one of those endpoints is called a covertex. Okay? Just like this, if it's standing up instead of laying down. And that's the center of the ellipse. The basic formula for an ellipse is x squared over a squared plus y squared over b squared is equal to 1. A squared will always be the bigger of the two numbers. For instance, if this is 25 and this is 149, the a squared would be the bigger of the two. Yeah. Let's take a look at this. Let's graph these. Graph. Identify the vertices, the covertices, the length of the major and minor axes. Find the foci. We're not going to do that today because of time constraints that we have with the remainder of the time in the school year. So what I'm going to do is just show you how to graph this thing, and then we'll find the major and minor axes and so forth and so on. Just like with the circle, I can think of x squared as x plus 0 squared over 16 plus y plus 0 squared over 9 is equal to 1. Just like we did with the circle. That was our first lecture. now we can see our center. It's 0, 0. There's the center of our ellipse. And we use these numbers here to determine where our vertices and our co-vertices are. Underneath x, we take the square root of this number, and on the x-axis, or horizontally, from the center, we go the square root of this, which in this case, the square root of 16 is 4. We'll go from the center, 4 to the left, and 4 to the right. That gives us the endpoints of our major axis, because 16 is bigger than 9. And I take the square root of this, and it's under y, so I go up and down 3. The square root of 9 is 3. And I can't begin to tell you how weird this is, just doing this without anybody asking questions and me turning around saying, does that make sense? And you say, oh, could you repeat that? It feels all very weird, so I'm just trying to make this make sense. Hopefully it does. Once we have these points, we can go ahead and sketch our ellipse. Try not to make it look like a diamond. There's our ellipse, and we want to find the vertices, the co-vertices, and the length of the major and minor axis. So we'll go vertices, co-vertices, the length of the major axis, and the length of the minor axis. And we're going to ignore, again, we're going to ignore the foci just because of time constraints. The vertices are these points right here. They're always on the end of the line segment that cuts it in the ellipse in half the long way. So there's a vertex and there's a vertex. And when it asks us to find them, we want the coordinates of those points. So this will be over 4 up 0, so that's 4 to the left up 0. And 4 to the right up 0. From the center, 4 to the right up 0. And sometimes you'll see that written as plus or minus 4, 0. This is a way of writing both of these in one expression. Okay? I'm going to write them like this, but you can write 2 ordered pairs like this if you want to. But for now, we won't do that. Okay, our co-vertices are at the endpoints of the line segment that cuts our ellipse in half the short way. So that'll be these points right here. And I want the coordinates of those points. So I go over 0 up 3 and over 0 down 3. So my co-vertices would be over 0 up 3 and over 0 down 3. The length of the major axis is this line segment right here. It cuts it in half the long way. And I want to know how long is that thing? Well, from here to here is 4, and from here to here is 4. The length of the major axis is 8 units. And we want to find the length of the minor axis. Let's see if I can move that. Yay! Length of the minor axis will be the length of the line segment that cuts the ellipse in half the short way. And if from here to here is 3 and from here to here is 3, then the length of the minor axis is 6 units. And that's all we were asked to do because we're not finding the foci for today. We graphed it. We found the vertex, the vertices, the co-vertices, the length of the major axis, and the length of the minor axis. We're going to do that again with this one. In this case, we're going to have to use our counterintuitive thinking to find the center of our ellipse. Just like we did with a circle, we're going to find the center of this ellipse by using counterintuitive thinking. It's going to go exactly the opposite of the way that we would think it was going to go. So I'm going to find the center of my ellipse. It's going to be at -1, 2. There's the center of my ellipse, counterintuitive. So here it is, -1, 2. Now from here, going horizontally, is going to be whatever number is under the x. I'm going to take the square root of that, and I'm going to go that many units to the left and right of my center. So I'm going to go to the left 3 and to the right 3. Here's my center. The square root of 9 is 3. So I'm going to go to the left 3 and to the right 3. If I can count to 3. 1, 2, 3. Yay. And then underneath y, I'm going to go up and down from the center of the ellipse. I'm going to go up 5 and down 5, the square root of 25. So I go up 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And there's my ellipse. I tried to draw a nice, beautiful ellipse, and that did not work. My board's broken. Let's see if it'll work now. Yay! So there's our ellipse. That looks horrible. And what else do I want to find here? It said to graph it, and what else did it say to do? Identify the vertices, the co-vertices, the length of the major and minor axis. So I want to find the vertices, the co-vertices, the length of the major and minor axis. So here we go. The vertices from the origin. You always mark your ordered pairs when you're trying to locate them in space. From the origin, I'm going to go 1 to the left and up 7. That's the coordinates of that point right there. Those are the coordinates of that point. So 1 to the left, up 7. That's one vertex. The other vertex, from the origin, I'm going to go 1 to the left and down 3. That's that vertex. 1 to the left, down 3. We're just finding coordinates of these points. When it asks for a vertex or a co-vertex, we want just the coordinates of the points only. To find the co-vertices, we do the same thing, except we're looking for these points right here. The coordinates of those points. So, from the origin, I'm going to go 4 to the left and up 2. I'll do that in a different color. It'll probably show up a little better. 4 to the left and up 2. That's this one. And the other one would be from the origin, 2 to the right, up 2. And normally I would tell you guys, if you see me make any mistakes, tell me. But since you're not here, I'm just hoping I'm not making any mistakes. Okay. Length of the major axis. That's the length of the line segment that cuts this thing in half the long way. That's this line segment right here. And so if I go up 5 and from the center and then down 5 from the center, the length of that thing has to be 10 units. So the length of the major axis is 10 units. And the length of the minor axis, from here, if I go 3 to the right and 3 to the left, the length of the minor axis has got to be 6 units. And that's how you graph an ellipse. You don't have to show these, you don't have to draw those axes in there. It doesn't hurt if you do, but you don't have to draw the axes. I was just sticking them in there to illustrate what it was we were talking about. If you're going to graph an ellipse, you find the center of the ellipse, and then you go left and right, the square root of whatever's under x, and up and down, the square root of whatever's under y. Again, we found the center, counterintuitive, -1, 2, and then we went left and right, 3, from the center of the ellipse, and then up and down from the center, 5. Take the square root of these, because that's a squared, and b squared. So a and b are the square roots of those. I think we're good on ellipses. Normally I would like to ask some questions, or have you guys ask some questions, but we can't do that. The worksheet will be multiple choice. You'll be given an equation, and then you'll be given the graphs of 4 ellipses, and you have to pick the ellipse that has the right center, the correct center, the location of the center, and the correct major and minor axis. You can do this. Good luck.